Okay, for this one, I apologize. I led you astray. I copied the problem wrong. Um, this was supposed to say secant. Both of these were supposed to say secant. It doesn't simplify very nicely when the way that it was originally written, and you'll notice my notes in the answer key. So let's solve this because this is a good principle um, uh, in case you see that on the test. So you have, if you're asked to simplify something, think about um, kind of making two things, which we have two terms here, and making it one, combining them. So, these two terms are both rationals or quote unquote fractions. And so we really should think about adding them. Now, you can't add two fractions unless they have the same denominator, and clearly they have different denominators. So, as messy as this is going to start, um, you have to do what what you need to do is make sure each denominator looks like the other. So I am going to take this first term and I'm going to give this denominator the other one. But I must make it as part of a same over same 1 as a factor. And I'm going to do the same operation on the other side. Here was the original term, and I'm going to give it the denominator factor that it didn't have, and I'm going to form a 1 on top. The reason that I'm doing that is because, and you'll want to notice patterns that look like this. When you have an a minus b somewhere and an a plus b somewhere else, what you need to know is when you multiply them, and you will when you multiply these two, which are the same, and make the denominator, when you multiply these two binomials, you get a squared minus b squared. This is difference of two squares. Normally you've seen this when you've been practicing factoring, and you know that you can factor it into these two binomials, and I'll give you an example. I think you all know instinctively that x squared minus 9 is x plus 3 times x minus 3. Well, you see the pattern. A, B, A, B. Only difference is these two things. And this is a perfect square, and that's a perfect square. Okay. So what we have on the bottom, here's our A and B, A, B, is a squared, which is the secant, minus b squared, which is 1 squared. That's what we have as our denominator, and they're both the same. But on top, we have this long thing. Okay? But this sign is multiplying to this binomial, so I have to distribute. And I have to say sine times that secant minus sine plus, and I'm going to distribute sine secant plus sine. So that's a little bit messy, but let me write that top part again. Sine secant minus sine plus sine secant plus sine. That's the top. The bottom of our expression is this, which, if you know your Pythagorean identities, is this. That was the whole point. And I'm sorry again that I did not have that in the original problem. But here's the thing that you may notice. When you look here, you have a negative sine x term and a positive sine x term. So what happens? They cancel each other out. And then you have two identical terms. So really, what we're writing here is 2 of these over tan squared of x. What is tan squared of x? Now I'm going to kind of, since this is essentially a fraction, I'm going to turn it into sine squared x over cosine squared x, which is the definition. It's getting long, but now I'm going to do keep this, change, and then flip. And I'm going to multiply this times cosine squared x over sine squared x. Okay. But then one more thing. I am going to replace that secant with what it truly is in terms of sine and cosine, 1 over cosine. Okay, so I kept this top, but I converted it, and I'm multiplying by the reciprocal of my denominator. And this is, sorry, this is long, this is the final step. You see you have 2 sine x's down here, multiplied. I have 1 up here. I can cancel one of these for one of these, which is why I'm erasing the square. And I have 2 cosine x's up here, and I can cancel one of these, which reverts it to just a single cos x, with one of these. So what do I have left in the end? 2 cosine x. And what's the definition of this? This is a single trig function, and it's simplified.